Um, just if you're rolling in, just so you know, there is no do now or exit ticket today. So you guys can basically just relax for now and take a break or whatnot. Hopefully everyone's shortened day. Well, it's only second period, but hopefully the rest of it goes smoothly. You don't have too much to do. Hey to there. Again, for people coming in, it seems like everyone has their cameras on, so thank you for everyone who has their cameras on. And there is no exit ticket or do now today, so you guys can just relax while the other students come in, and then I'll get started on what we're talking about today. Hey Kata, hey Favor, how are you guys? Hey DJ, hey Kalia. Welcome to everyone joining. So for everyone joining, just have your sound on, video off, unless you are on the video permission slip form type thing. The list of the students is right there. So Habidat, Steve, Precious, Kaylin, and Mubarak. You guys are all okay to not have your videos on. Everyone else should have their videos on for right now. And then as people are rolling in, for the people who've just come in the last minute or so, there is no do now or exit ticket today. So you can look forward to not having to do the exit ticket. I am still expecting people to turn in their class notes for today. But again, you guys can just relax for the first portion of class as we just wait for everyone to join. Hey, Clarissa. Cool. I'm gonna wait approximately 1 more minute or so before I really start talking about stuff. Hey, Jenny. Anyone have any special plans for this weekend? Might be one of the last weekends before we're returning to like hybrid learning and stuff, right? I haven't really even thought that far ahead, but apparently that's happening soon. Oh, Ashley said that you're hanging out with Jenny. That's really cool. Awesome. Yeah, I've always wondered like who in my classes are friends, because like I can't tell anything on Zoom, but yeah, it's awesome. Marche said, gonna watch Miami ruin the Celtics career in game 3. Nice. Yeah, I'm officially like rooting for Miami now, I think, out of the teams that are left. I don't know. Risha said going upstate. Cool. Going anywhere in particular, just like, and for any particular reason? Emily said completing all missing /late assignments. Awesome. That sounds, I'm sorry about that, but I mean, obviously that is a smart move. Although if I were in your place, I definitely, yeah, probably not the most fun thing for you, but I'm glad that you're committing to that. Jordan said that he is hanging out with Jenny too. Cool. Okay, I'm getting more messages about people hanging with Jenny. I'm assuming you guys are all telling the truth, but if so, Jenny, you are very popular. So good for you. I'm just gonna believe it, all of you, that you guys are all gonna hang out with Jenny. Probably at the same time, right? Like if you guys are all individually hanging out with Jenny, then she has a okay, understood. I assumed some of them had to be lying. Okay. Precious said that they're all lying. Jenny said they're all lying. So I mean, okay, that's got to be a big deal. Okay, everyone's trolling everyone right now, or you guys are all trolling me. I have no idea what to believe. So, Ashley said her real name is Jen Frazier. Okay, judging by the reactions, I probably should not have said that out loud. So, sorry about whatever that caused, but okay. Hopefully you guys are all like just joking with each other. But anyway, okay, so I'm gonna start talking about actual stuff today. So homework packet 1 is due today. So I know it seems like I'm being nice by not giving you guys a due now or exit ticket, but not really, because you guys have homework packet 1 due today. So make sure you get that in. And then the homework 1 packet video tutorial is uploaded to YouTube. That's just another reminder. It's been up there for like a few days now. And again, I managed to finish the packet in 30 minutes, like a packet that was extremely similar to the one that I assigned. Obviously, like I'll probably work faster than most of the students in this class. But again, my point is if you want to put the video on and like work through the packet along with the video, I think you should be able to get it done and get it done correctly. Again, I am grading this packet for correctness. So prioritize that for today. Let's see. Okay, it looks like most students' videos are on, so thank you for that. I see some people still with their video off. I'm supposed to like really be insistent on having your videos on, so please try to have your videos on. Again, the list of students who are approved is right there. Okay, yeah, I'm getting messages from people, so I see those messages for if you can't have your video on, so thank you for that. Next, just get organized, have your notebooks out, and then make sure you finish your homework packet today, because there will be another homework packet coming out this weekend. And again, I don't think it should take very long. It should be the same deal as homework packet 1. Depending on like student feedback and like how well students are doing, I might make it shorter. I might make it longer if it seems like everyone did it on time and it wasn't that hard. I'll see. I'll take a look at the feedback. So yes, that is what we have for now. Okay. Next, I have some updates. Grades updates. So the gradebook should be updated all the way through September 11th now, minus the summer assignments. So if you guys are looking for the summer assignments, it's not in the gradebook right now. And that will impact your grade. Right now, it will impact your grade significantly because all these summer assignments were extra credit. I'm not sure if you guys know that. I think that probably applied to other classes too, but all the summer assignments were extra credit. So like literally, I was like close between like 20 to 50 points of extra credit for if you did the summer assignments. Like, so you'll probably have more than an A+ because like I don't even know if we've had 50 points so far. But yeah, so check the gradebook if you think there's something wrong, and then just email me if you're concerned about anything. Next, I got a message asking me why is it considered extra credit. I'm not really sure. This was not my decision because I wasn't like employed when they assigned all this extra credit homework, but like Mrs. Sladek informed me, and like that's just the policy that I don't know, the school is doing for math at least. The summer assignments are all extra credit. So, I mean, that should help you guys.
Hi, Mr. Wang.
Yeah, what's up?
I can jump in here. Hi, y'all. Miss you guys.
Hi, Mr.
Hey, Kimberly.
Hi, Mr. Roan.
Hi, y'all. I can jump in as to why it was extra credit. With everything that has happened with remote learning and with COVID and with this huge transition, I think that it would have been better to start everyone on a positive note instead of if you did not do it, then your grade would have severely suffered. But if you did get a chance to do it, your grade would have highly benefited. So if you did do it, this is like super great for you. And if, you know, God forbid something happened, you lost a family member, if you were really sick, someone around you was really sick, and, you know, if this wasn't highest leverage for you this summer, then you did not get a chance to do it, that this is not, you're not starting off your senior year on the wrong foot. So I think keeping that positive mindset of like, this is your senior year and you're about to start calculus with like your grade as high as possible, or just like this like solid foundation, it's going to be great. So that's why it's extra credit. Just wanted to jump in there for that.
Awesome. Thank you, Ms. Jerome. Yeah, so yeah, that should all help you out for your grade, and hopefully it helps you out in case you were having difficulties this summer, as I'm sure we all did. One thing though, I would try to make sure, even though your grade might look really high right now, if you have any missing assignments, you should still turn it in, because the buffer for the extra credit is ideally, I don't think it's going to last for the entirety of the semester. So again, if you have any exit tickets or like class notes that you still want to turn in for partial credit, my policy for this is I'm going to give partial credit, but I need, if you're going to turn stuff in late, I would like for you to like complete the assignments that you're turning in late, and then send me an email with a list of the assignments that you turned in late, because it's really difficult for me to keep up with like every notification for every assignment that people turn in late if like you're turning it in after I grade them already. So again, I would like if students can do that, and I'll just do my best to catch every assignment that like slips through the cracks and whatnot. Next week, I'm going to be holding my first office hours. So I posted a link for a when to meet. I'm not sure if you guys have used this before, but it's just a really quick thing. You don't have to sign up for anything. You literally just go on the site. I think I can show it really quick, actually. So when you click on that link, which is also on the Google Classroom, you're going to be sent to a page that looks like this. And on this page, you would just input your name. So for me, I put William. I sign in. And then over here, I would just make the times that I'm available green. So from 9 a.m., let's say on Monday, to noon, I'm free. And then I just click on Tuesday from 9 a.m. to 4 p.m., let's say I'm free. And then that would show up. And then I could see which times would be like, which times would help the most students. And yeah, I can put the name in the chat. Actually, that's a good idea. I should have done that. Sorry, give me 1 second. Oh, that did not work. Okay, so that should be sent to everyone in the in the class. So everyone can take like 1 minute right now to actually click on that and fill that out for whatever time works for you. Again, just put in your name and then click on the times that work for you. I'm gonna give 1 minute so that we can move on to some content. Okay, 10 more seconds to fill out the when to meet. Okay, so if you aren't able to fill that out now, please fill that out sometime after class, but we're gonna move on to today's content. So first I wanna address, well, first everyone get their notebooks out, and then today is basically a review day, although we will be emphasizing more intermediate value theorem, which is what we covered yesterday. So if you want to put in intermediate value theorem, continued plus review, then go ahead and do that. I'm going to give 30 seconds for everyone to set up their notebooks. Okay, so starting with yesterday's exit ticket, I was looking at yesterday's exit ticket, and this is like, I think my fault because I chose problems that I don't think were the best. So if you struggled with yesterday's exit ticket, I would not worry. But that's also why I'm kind of reviewing some of the same content that we went over in yesterday's exit ticket. So again, this terrible, that's on me. I think the first problem I chose, I was like rereading the wording of it, and it can be really confusing. So use intermediate value theorem to prove that the equation 3x to the fifth minus 4x squared equals 3 is solvable on the interval of 0 to 2. This is essentially saying that the function f of x equals 3x to the fifth minus 4x squared is equal to 3 at some point on, well, I won't write this out, on this interval from 0 to 2. And I think the way I just said it is much more clear than saying the equation is solvable, because there's no like, doesn't say y is equal to 3x minus 5, so it's like kind of confusing. So if you weren't really clear on that, that's totally fine. If you gave it your best shot and answered something, I'm going to accept it. And the second question is actually a really great question, but it is kind of difficult, and I don't think many people got it. And this test, if you remember yesterday, right, looking at our second problem on the exit ticket, basically one of the prerequisites for the intermediate value theorem is that the function must be continuous, right? So we can plug in f of -1 is equal to -1, right? And f of 1 is equal to 1. So it looks like in between that interval, between -1 and 1, there's going to be a 1/2. However, we have to first check if this function is continuous, and we kind of have to do that intuitively. And if we think about it on this interval from -1 to 1, at x equals 0, right? When it's f of 0, it's going to be 1 over 0, and we're going to get an asymptote. And when there's an asymptote, we are obviously it's not going to be continuous. So basically, intermediate value theorem doesn't apply in this case. So we cannot guarantee because it's not continuous. And that's what we have to emphasize here. So there's kind of two parts to intermediate value theorem, which we will go over more in depth with our remaining like 15 minutes of class. For this exit ticket, I would say copy down this problem in your notes if you are able to, or if it's like in your exit ticket notes, like your exit ticket work, that's totally fine too. I'm not like, when I check notes, I'm not like a super stickler checking that you have every component, but if you have this in your exit ticket, that's fine. But this is a good problem. So I'm going to give people maybe 15 seconds or so to catch up on any notes that you still have. Okay, cool. So now we're going to go over a quick review of intermediate value theorem, which we discussed yesterday. So I'm just going to take a look at the definition one more time. So a function y equals f of x that is continuous on a closed interval a to b takes on every value between f of a and f of b. I would like for everyone to copy this definition in their notebooks one more time for today, although I'm sure that everyone already copied it yesterday. And I would like for everyone to just draw a rough sketch of this graph. And these are the critical components: A, B, f of A, and f of B. And then the graph and how that corresponds to the graph. So please take 30 seconds to a minute to copy this down. And as you're copying it down, try to think about what the sentence really means, what the definition really means. Okay, cool. So let's take a closer look at what this means one more time. So a function that is continuous on the closed interval of a to b. So let's take this first part. Take a look at this first part. So on the interval of a to b, now these are x values, right? X values, right? A and b over here are x values. They are on the x-axis, right? So on this interval on the x-axis, we're saying that y equals f of x, this function is continuous. So if it's continuous, so this function right here from a to b, right, it's continuous because, again, we're just doing a casual test showing that I don't have to pick up my pen, right? I can just draw this function without picking up my pen. Cool, so that first part of our definition is met. Now let's take a look at the second part of the definition. It takes on every value between f of a and f of b. F of a and f of b. Now I think this might be kind of confusing. Like, what are f of a and f of b? And like a and b, it's kind of confusing. Well, we already clarified that a and b are x values. A and b are x values. Well, f of a and f of b are y values, right? F of b is here, f of a is here. So what this really means is, like, let's say I have a function that's like x squared, right? And I'm saying the x values from the x value at 2, right? So this would be a function f of x right? And then the x value is 2. But when I plug in 2, I'm going to get f of x is equal to 4. Remember, so it's a function. So these are really the y values. So it's like the corresponding y values. The corresponding y values is what we're paying attention to in the second part of the theorem. So basically what we're saying is that a function that is continuous from a to b here, it takes on every value between these corresponding y values. So every value between here, you'll notice is covered, right? So like this point is covered, that is covered, there is a point there, they all exist. It all exists. Now the moment you get beyond this value, like f of b, let's say a tiny bit beyond this value, oh, sorry, it does exist, right? It does exist, but it doesn't necessarily have to. It doesn't have to exist. For example, I could draw a continuous graph that looks like this. Right? It's continuous from a to b, and it goes from f of a to f of b. Now all of a sudden, if I'm right above f of b, it doesn't exist. It does not meet this point. So hopefully you guys are able to visualize what that means. Like a and b and like f of a and f of b, they're just x values and y values. Okay, so now we can apply this definition very directly. So this is an example AP problem. And it states, let f be a function that is continuous on the closed interval of 1 to 3. Okay, so that tells us that this function, again, from 1 to 3, which are the a and b values, is continuous, right? Cool. Well, that's easy for us. Now we know this first part of the equation is already met, so we can apply intermediate value theorem. And then we're told that f of 1 is equal to 10, and then f of 3 is equal to 18. So we know it's continuous, and we know it goes between 10 and 18, right? It goes from 10 and it goes up to 18. So now I would like for everyone to read the multiple choice answers and tell me which one is true. And there's only one answer that is true, that must be true, sorry. And then a lot of the answers could be true, like it's possible, but they don't have to be true. So only one answer has to be true because of intermediate value theorem. I'm gonna give everyone 1 minute to try to solve this problem. And then once you get your answer, please message me in the chat. Again, everyone should be working on the example AP problem right now. Awesome, thanks Tavera, thanks Steve. So again, I think this problem is tricky because a lot of answers could be true, but there's only one answer that fits with our definition. So look for the answer that fits in the definition. Okay, another 15 seconds or so. I would like some more answers. So for people who haven't chatted anything, please chat what you think the right answer is. It's just one letter, so, okay. Thanks, Naima. Thanks, Jamal, Risha, Ashley, Kalia, Mubarak, Marche. People who I read earlier. Thanks, Alicia. Okay, so Kalia, thanks for typing out your thoughts. Dejay, awesome. Dejay, you did get the right answer. So thank you for that. So I'm gonna call on someone Let's see. Sever, could you come off mute and explain your thought process for your answer choice?
Okay, I got A, and I picked A because, huh?
Sorry, go ahead, sorry.
I picked A because it's saying that it's continuous between 1 and 3, and 2 is in the middle of 1 and 3, so the value of 2 would be in between 10 and 18 if we look back at the intermediate value theorem.
Gotcha. Okay, thanks for that. Okay, how about Jay? Go ahead. What are your thoughts on Sever's response, and what is your own answer?
Well, I would say I would agree. Because when we were making like a casual definition, like I kind of just said, it has to touch every point at some point in time. So when I'm looking back at the problem, and it says let f be a function that is continuous on the closed interval of 1 to 3, and it says f of 1 is 10 and f of 3 is 18, and I saw C and it said f of x is equal 17 has at least one solution in the interval of 1 to 3. And I remember my definition for it, and it has to touch every single point. It can't just jump over a point. So that's why I said C.
Awesome. Yeah, that's a really great way to think about it, and like great way to verbalize it actually. So C is the right answer in this case. I would say A is probably an answer I think that would trip, like even when I first read this problem, when I first like just skimmed A, I was like, oh, that seems like it could be right. But then you get to C and you see C fits perfectly with the definition of intermediate value theorem. Remember, it's continuous from 1 to 3, and that's between 10 and 18 in the Y values, right? And all intermediate value theorem tells us is that every value between 10 and 18 must be met. So 10.1 is met, 11 is met, 12 is met, 17, 16, any number between 10 and 18 is touched by this function. That's all that intermediate value theorem tells us, right? I'm going to kind of draw out what this graph might look like. So let's say we're between, here's 1, right? And here is 3. And then this would be, let's say this is 10, and this is 18, right? Actually, 10 is too high. You guys probably just have to visualize it because this is obviously not perfect. We know that these 2 points are connected, right? So every point between 10 and 18 must be touched. Now, why is A wrong? Let's try to think of an exception to A, right? This is saying that f of 2 must be between 10 and 18. Well, is that true? What if I draw the graph like this? So it's really high. It's like a reverse parabola. Now, where's f of 2? F of 2, if I correspond f of 2, it's like over here, right? So is that between 10 and 18? No, it's way above 18. This doesn't tell us that every point between 1 and 3 is met between 10. It's just telling us that every point between 10 and 18 is met. Because even if I draw this, you'll notice there's a point for every point between 10 and 18. Now, I also got the answer B that was pretty common in chat. The f is increasing on the interval of 1 to 3. Well, intermediate value theorem doesn't tell us anything about whether it's increasing or decreasing. The function could literally look like this, way down. Well, it couldn't look like that, but way down here, and then go back up, and it's obviously decreasing over here, right? So it wouldn't be B either. So again, think very objectively about what the definition means. And again, all that it tells us is that between 1 and 3, if we know that the function is continuous and we know that the values go between 10 and 18, then every value between 10 and 18 is met. So when we're asked, is 17 met? The answer is yes. 17 is met. So there's like probably 30 seconds left in class. Again, no exit ticket or, yeah, no exit ticket due. Just turn in a picture of whatever notes you took today. Make sure to turn in the homework packet that is due today, and then look out for homework packet 2 this weekend. And there will probably be some more intermediate values and problems in that. So you guys will get to do more practice. But thank you everyone for coming, and I'll see you guys on Monday. Bye, Clarissa. Brianna, yeah, I will take a look. I'm not sure if you were here at the beginning of class, Brianna, but if you have future assignments that maybe you haven't turned in, just in the future, if you could email me about those assignments, just because like if they're assignments I already graded, I don't really get notified, so it's like impossible for me to catch every single assignment that people like if I've already graded the assignment and someone turns it in later, I can't catch everyone. So you can just send me an email and I'll be sure to check on that. But I will check on that right now for that assignment. So thank you for that.